Okay, in this section 8-7, we're taking a look at orthogonal vectors. And so two vectors, u and v, are orthogonal when their dot product is equal to 0, right? When their dot product is equal to 0. And then along the same lines, two vectors are parallel if u equals some constant times v, right? Now let's talk about orthogonal. You may or may not have heard this term. Orthogonal and perpendicular, they mean basically the same thing, meeting at right angles. And typically, one of the ways that I've heard the difference between these two used is, I read one resource that says perpendicular refers to two things that are in a two-dimensional plane, like an x and y axis, like two lines. And orthogonal refers to meeting at 90 degrees in a three-dimensional plane. So, that could be particular to when you would use each term. All right. Let's see. Just talking about the 0 vector. 0 times the vector is equal to 0, right? Determining orthogonal vectors. So the question here is, are these two vectors orthogonal? Well, they would be orthogonal when their dot product is 0. So let's see if it is. So I want to do the dot product of u times v. And so that would be 2 times 6, which is 12, minus 3 times 4, which is 12. 12 minus 12 equals 0. So since the dot product is 0, the answer is yes. Okay, so if you were to draw these two vectors, 2, -3, and let's see, 6, 4, if you were to draw those two vectors out, you would see that they're 90-degree vectors. And a matter of fact, if we use the formula that we would use last time to find the angle between the two, you would see that the angle between the two is 90 degrees. Okay, that would be another way to see if they were orthogonal, but the faster way would be to just use the dot product. All right. Let me see here. Determine whether u and v are orthogonal, parallel, or neither. So if their dot product is 0, orthogonal. If there's a factor that you can multiply by 1 to get the same vector as the other, they're parallel. And if that's not the case for either one, then it would be neither. All right, so let's take a look at this one. Okay, so first of all, we want to go through and see if we can find the dot product. So the dot product of these two would be 39 times -26 plus -12 times 8. So that ends up being -1014 minus 96, which equals -1110. All right. So since the dot product is not 0, then we can say for sure that they're not orthogonal. Let's talk about parallel. So what's the easiest way to figure out whether they have a factor that would multiply by 1 and make it equal to the other vector? The easiest way would be to divide the common components and see if those divisions are equal. Then that would be the common factor. So we can go 39 divided by -26, and that would reduce to -3 over 2. And we can go -12 over 8, which is also -3 over 2. And so that would be the common factor. I can multiply v times -3 over 2 and turn it into u. And so that means that these two must be parallel. All right. What about these two? Let's see if the dot product is 0. So here, 8 times 5, 40, minus 40, equals 0. So the answer is orthogonal. All right. Okay, now, on this next type of problem, it's a little bit different type of question. It says, find the value of k such that the vectors u and v are orthogonal. Okay, so what they want us to do is they want us to find the value of k here, all right, for this component that would make them orthogonal, right? Okay, now, here's the thing. Okay, if these two were orthogonal, then the dot product would be equal to 0, right? So I basically want to find the value of k that would make the dot product here 0. All right, so how can we do it? Well, let's take the dot product of these two vectors. So 1 times 1 is 1, and let's see. So here, this would be negative k times 2 is negative 2k. And for these to be orthogonal, then that dot product should be equal to 0. Now I have an equation that I can solve for k. And when we do, this becomes negative 2k equals to negative 1. Divide by negative 2. And then the value of k is 1/2. So that's the value of k that would cause these two to be orthogonal. If you wanted to double check it, then you'd have 1 times 1 is 1, and then you would get minus 1/2 times 2 is 1, 1 minus 1 is 0. All right. Likewise, we'll do the same procedure in the next one. The dot product should be 0, so 2 times negative 1 is negative 2, and 1 times negative k is negative k. That dot product should be 0, and if I want to solve that, that would be k is equal to negative 2. All right, so that's it.